Welcome back to Tales from Africa, Unraveling the Hidden Truth. And our first episode, we journeyed to the cradle of humankind. We met the cast of ancient hominins, Australopithecus, Paranthropus, and our own emerging genus, Homo, who shared the African landscape more than 2 million years ago. We learned that human evolution is not a straight line, but a braided stream, a tangled bush of coexisting species, each competing for survival. And we began to see that our success was never inevitable. But how did we survive? How did our ancestors, small-brained and relatively weak compared to the giant predators of the savannah, manage not only to endure, but to thrive? The answer lies in a series of innovations, leaps of creativity and ingenuity that transformed our relationship with the world. In this episode, we fast forward from the cradle of creation to the dawn of innovation. We will explore the earliest technologies, the first stone tools, the extraordinary discovery of fire, and the development of hunting strategies that required intelligence, cooperation, and endurance. We will uncover the hidden truth of how Africa became the birthplace of human ingenuity, setting our ancestors on the path to global dominance. This is the story of how we became makers, shapers, and masters of our environment. Imagine for a moment you're a hominin living 2.6 million years ago in East Africa. The world around you is dangerous. Lions, leopards, and hyenas stalk the grasslands. Your diet consists mostly of plants, fruits, and perhaps the occasional scavenged carcass left behind by larger predators. You have no claws, no sharp teeth, no thick hide for protection. You are prey as much as you are predator. Then, one day, something changes. A flash of insight. Perhaps born of necessity or accident, you pick up a stone and strike it against another. A sharp flake breaks off. You hold it in your hand. It is sharp, capable of cutting. In that moment, the world changes forever. You have invented the first tool. This was the dawn of the Olduvai industry, named after the Olduvai Gorge in Tanzania, where these early stone tools were first discovered. The Olduvai, dating back to about 2.6 million years ago, represents the earliest known systematic production of stone tools by our ancestors. It was a relatively simple technology, striking two rocks together to produce sharp flakes that could be used for cutting, scraping, and butchering. But don't let its simplicity fool you. This was a revolutionary leap forward. As Ignacio de la Torre, a scientist at the Spanish National Research Council who leads the Olduvai Gorge archaeology project, explains, this technology marked a profound shift in human capabilities. The Olduvai spanned between 2.6 and 1.5 million years ago and is characterized by the production of stone-sharp flakes through striking two rocks against each other. These simple stone tools allowed our ancestors to access new food sources. With a sharp flake, they could cut through the hide of a dead animal, exposing meat and marrow that had previously been inaccessible. This dietary expansion, the addition of animal protein, was a critical factor in the evolution of larger brains. The more meat our ancestors ate, the more energy their brains had to grow. The Olduvai was just the beginning. Around 1.7 million years ago, a new technology emerged, the Acheulean. This was marked by the appearance of hand axes, large, robust, almond-shaped stone tools that required remarkable technical skill to produce. These were not just simple flakes. They were carefully crafted tools, shaped on both sides to create a sharp, symmetrical cutting edge. The Acheulean represents a significant cognitive leap. To make a hand axe, a toolmaker had to plan ahead, envisioning the finished product in their mind before they even began. The Acheulean technology is well known by the conspicuous presence of hand axes, which are large, robust, often pointed and almond-shaped stone artifacts and whose production requires remarkable technical ability. The transition from Oldowan to Acheulean was not just about better tools. It was about a new kind of thinking, a more complex understanding of raw materials, planning, and design. The Acheulean toolkit also included a surprising new element that would push the timeline of human innovation back by a staggering 1 million years. For decades, archaeologists believed that the systematic production of bone tools was a relatively recent development, appearing in Europe only around 400,000 to 250,000 years ago. The prevailing view was that bone tool making in Africa was rare, sporadic, and not a regular part of early hominin toolkits. Then, in 2025, a discovery at Olduvai Gorge shattered this assumption. A team led by Ignacio de la Torre and Jackson Yao uncovered an assemblage of 27 bone tools shaped by napping within a single stratigraphic horizon dating to 1.5 million years ago. These were not just casual opportunistic uses of bone fragments. These were systematically produced standardized tools made from the limb bones of massive animals, hippopotamuses, and elephants. Before this discovery, De la Torre explains, our understanding of the technological transition was incomplete. Prior to our discovery, the technological transition from the Oldowan to the Acheulean was limited to the study of stone tools. But this discovery changed everything. It revealed that early Acheulean toolmakers had developed a cultural innovation that involved transferring and adapting their stone napping skills to bone. They understood the anatomy of the animals they hunted and scavenged, which bones were strong enough, which could be shaped, and how to work them into useful forms. The bone tools were not just expedient substitutes for stone. They were a deliberate technological choice. Some of the tools, made from elephant bones, measured up to 38 centimeters in length, massive implements for heavy-duty work. By producing technologically and morphologically standardized bone tools, early Acheulean toolmakers unraveled technological repertoires that were previously thought to have appeared routinely more than 1 million years later. This discovery pushes back the timeline of systematic bone tool production by more than 1 million years. It demonstrates that by 1.5 million years ago, East African hominins had already developed sophisticated technological repertoires that included both stone and bone tools. They were no longer passive participants in their environment, reacting to the world around them. They were active shapers of it, capable of innovation, planning, and the transmission of complex knowledge. What does this mean for our understanding of early human cognition? De la Torre suggests it hints at significant advances in cognitive capacities. Additionally, this enhancement of the technological potential hints at advances in the cognitive capacities and mental templates of these hominins, who understood how to transfer technical innovations from stone flaking to bone tool production. The world of 1.5 million years ago was not just about eating and survival. It was about learning, adapting, and teaching. The systematic production of bone tools would have required social learning, the transmission of knowledge from one generation to the next. It required an understanding of cause and effect, of material properties, and of the underlying principles of toolmaking. Our discovery indicates that from the Acheulean, no longer were animals only dangerous, competitors, or just foodstuff, but also a source of raw materials for producing tools. Fire. It is one of the most transformative discoveries in human history. It provides warmth, protection from predators, and light in the darkness. It allows us to cook food, making it easier to digest and releasing more nutrients. It fosters social interaction, creating a gathering place for communities to share stories and bond. The control of fire was a turning point in human evolution, a force that shaped our biology, our culture, and our very humanity. But when did our ancestors first tame the flame? This is a question that has long intrigued archaeologists, and the evidence points firmly to Africa. Until recently, the most widely accepted evidence for controlled fire use came from Gesher Benot Yaakov in Israel, dating to about 790,000 years ago, but a study published in 2021 provided compelling evidence for fire use in Africa at least 1 million years ago, pushing the timeline back by 200,000 years. The discovery comes from Wonderwerk Cave in South Africa. Archaeologist Michael Shazan and his team found visible signs of burning in a layer dated to 1 million years ago. Using microscopic analysis and infrared spectroscopy, they examined the sediment and found angular, sharp-edged bone fragments and well-preserved plant ashes. The presence of these particles, unrounded and undisturbed, indicated that the fire had taken place inside the cave, rather than being blown in by wind or water. I think this research establishes as well as possible that by 1 million years ago, early humans were able to control fire. The analysis also showed that the bone mineral had been heated to temperatures between 450 and 700 degrees Celsius, the temperature of a small campfire. This was not a natural forest fire which typically burns at lower temperatures. It was the controlled use of fire by early humans. Before this, I didn't believe that humans use fire so early, but there's no other explanation. But the evidence goes back even further. At Swartkrans in South Africa, researchers have found burnt bones that were heated to very high temperatures, again consistent with the controlled use of fire. At Chesawanja in Kenya, red clay class dating to 1.4 million years ago suggest heating to 400 degrees Celsius. At Kubifora, also in Kenya, reddened sediment at 1.5 million years ago hints at fire use. The findings from Wonderwerk Cave fit perfectly with what we know about Homo erectus, our ancestor who roamed Africa as early as 1.9 million years ago. Harvard primatologist Richard Wrangham has argued that the relatively small molars and small gut of Homo erectus suggest it ate soft, nutrient-packed cooked food. And the fact that Homo erectus slept on the ground, rather than in trees, suggests that it had already begun building campfires to deter predators. The control of fire was more than just a source of warmth and protection. It was also a sophisticated engineering tool, a technology that allowed early humans to transform raw materials in ways that were previously impossible. Around 72,000 years ago, at a site called Pinnacle Point on the southern coast of South Africa, early modern humans demonstrated a genius moment. They discovered that heating a stone called silkrete, which was otherwise poor for tool-making, dramatically improved its properties. The heat altered the stone's color and grain structure, making it easier to flake and shape into sharp tools. This was not a simple matter of throwing a stone into a fire. The heat treatment process required careful control, heating the stone to between 300 and 400 degrees, maintaining that temperature for 2 to 3 days and then allowing it to cool slowly. These people had very good control of fire, and I'm almost certain they must have had language to carry out that sort of behavior. This discovery pushes back the earliest evidence of heat treatment of stone tools by at least 45,000 years, possibly even 139,000 years. Before this, it was thought that such technology first appeared in Europe around 25,000 years ago, but here, on the southern tip of Africa, early modern humans were already masters of fire and engineering. Heat treatment technology begins with a genius moment. Someone discovers that heating stone makes it easier to flake. Why would our ancestors invest so much effort in this complex process? The silkrete tools they produced were reusable, highly effective as hunting weapons, excellent knives, and items of value for exchange. The effort was worth it. This technology gave them a crucial advantage, an advantage that would help them survive in colder climates and compete with other hominins. Here are the beginnings of fire and engineering, the origins of pyrotechnology, and the bridge to more recent ceramic and metal technology. The command of fire, documented by this study of heat treatment, provides a potential explanation for the rapid migration of these early modern humans out of Africa. Around 50,000 to 60,000 years ago, they left the warm confines of Africa and penetrated the colder glacial environments of Europe and Asia, where they encountered Neanderthals. By 35,000 years ago, the Neanderthals were extinct, and modern humans dominated the land from Spain to China to Australia. They were masters of fire and heat and stone, a crucial advantage as these tropical people penetrated the cold lands of the Neanderthal. The dawn of innovation was not limited to tools and fire. Our ancestors also developed sophisticated hunting strategies that relied on intelligence, cooperation, and a unique human physical trait, endurance. Persistence hunting is a technique in which hunters use a combination of running, walking, and tracking to pursue prey until it is exhausted or overheated. Humans are the only surviving primate species that practices persistence hunting. Our relatively hairless bodies and our ability to sweat effectively allow us to cool down while running, giving us a significant advantage over furry, panting prey. This strategy is believed to have been one of the earliest hunting techniques used by humans, and it is still practiced today by the San people in the Kalahari Desert. In a typical persistence hunt, a hunter chases an antelope such as a kudu in the midday heat for up to 5 hours and a distance of up to 35 kilometers, in temperatures as high as 42 degrees Celsius. The animal is repeatedly tracked and pursued until it is too exhausted to run, at which point the hunter kills it with a spear. But could Homo erectus, our ancestor from 1.5 million years ago, have used this technique? A study published in the Journal of Human Evolution in 2020 used mathematical modeling to find out. The researchers simulated the conditions of persistence hunts and estimated the water loss in Homo erectus. The results were striking. Our results showed that H. erectus would reach the dehydration limit in 5.5 to 5.7 hours of persistence hunting at the reported Kalahari conditions, which we argue represent a conservative model also for early Pleistocene East Africa. This means that Homo erectus could persistence hunt large prey for over 5 hours without needing to drink, sufficient time to run down a kudu or similar large animal. The researchers concluded that dehydration was not a limiting factor for persistence hunting in Homo erectus. This discovery is significant because it suggests that our ancestors were capable of endurance running and sophisticated tracking long before the invention of water containers or complex weapons. Persistence hunting would have required more than just physical endurance. It required cooperation, hunters working together to track and pursue prey. It required tracking skills, reading the signs left by animals on the landscape, and it required communication, coordinating movements and strategies. This hunting strategy would have driven the evolution of key human traits: endurance, social cooperation, and cognitive abilities. The dawn of innovation was not a single event, it was a gradual, accelerating process of discovery and transmission. It began with the first stone tools, a flash of insight that allowed our ancestors to transform their relationship with the world. It continued with the systematic production of bone tools, a cultural innovation that pushed the boundaries of technological possibility. It was powered by the control of fire, a mastery that provided warmth, protection, and the ability to engineer materials. And it was driven by hunting strategies that required endurance, cooperation, and intelligence. Each of these innovations built on the last. The stone tools of the Oldowan gave way to the hand axes of the Apuleian. The understanding of stone knapping was transferred to bone. The mastery of fire led to the heat treatment of stone and the creation of pyrotechnology. And the hunting strategies of Homo erectus laid the foundation for the modern human physique and cognitive abilities. This is the hidden truth of Africa's early history. It was not a continent of passive, primitive people waiting to be civilized by outside forces. It was the birthplace of human innovation, a crucible of creativity, experimentation, and adaptation. The innovations that emerged from Africa, tools, fire, hunting strategies, were not just local achievements. They were the foundations of human civilization. They allowed our ancestors to survive, to thrive, and ultimately to leave Africa and populate the entire world. As Curtis Marion noted, the command of fire and engineering gave our ancestors a crucial advantage as they penetrated the colder climates of Europe and Asia. The mastery of heat and stone technology would have been an invaluable asset in a colder world, and the story did not end there. The innovations that emerged in Africa, the tools, the fire, the hunting strategies, were the seeds from which all future human technologies would grow. The first stone tools gave rise to the complex technologies of the modern world. The control of fire led to the development of ceramics, metallurgy, and eventually the Industrial Revolution. The hunting strategies of Homo erectus laid the groundwork for the social cooperation that would become a hallmark of human society. In our next episode, we will journey forward to the rise of the first kingdoms and the birth of social order. We will explore how these early innovations, tools, fire, and hunting, laid the foundation for the complex societies that would emerge across the African continent. We will uncover the hidden truth of how Africa became the birthplace of civilization itself. But for now, remember this: the dawn of innovation was an African dawn. The first tools, the first fire, the first systematic production of bone tools, all of these happened in Africa, long before anywhere else in the world. The ingenuity, creativity, and adaptability that define our species were born on the African continent. Thank you for listening to this episode of Tales from Africa, Unraveling the Hidden Truth. I'll see you next time.